You're walking through an old city. On the left, you see a rusty iron bridge glowing red like a sunset. On the other side stands a centuries-old copper statue, green like a frog that sat in the pond too long. Both are metals, both rust. But why do they look so completely different? Iron oxidizes reddish-brown, copper turns green. Why? It's as if each metal has its own opinion about how it wants to age. Welcome back to our channel. Today we're looking at why metals don't just rust, they also hold a color competition while doing it. Every metal reacts differently with air, water, and time, and these reactions tell stories in color. Let's start with iron, the classic loser in the fight against time. Everyone knows rust. That red-orange, crumbly stuff that makes old bicycles look like archaeological finds. But what actually is rust? Chemically speaking, it's iron oxide. More precisely, a mixture of various iron oxides and iron hydroxides. Sounds complicated, but it's basically simple. Iron reacts with oxygen and water. The result? A new compound that happens to be red. But why red? The color comes from the way iron oxide molecules absorb and reflect light. Imagine light is like a buffet full of colors. Each molecule picks what it wants to eat, meaning which wavelengths it swallows. Iron oxide devours the blue and green waves and leaves only the red and orange ones. What's left over is what we see. That's why rust is red. It's not the color that iron oxide has, but the color it doesn't want. And here's where it gets nasty. Rust is porous, brittle, useless. It doesn't protect the underlying metal. On the contrary, it lets water and air through like a leaky umbrella. That's why iron keeps rusting, layer after layer, until, in the end, only red powder remains. Iron doesn't age gracefully. It disintegrates dramatically. Now to copper. Copper is the exact opposite. It ages like a fine wine, with style and a certain elegance. When copper reacts with air and moisture, a green layer forms, the so-called patina. Chemically, this is mainly copper carbonate and copper sulfate, depending on what's floating around in the air. Near the coast, where there's a lot of salt in the air, the patina becomes blue-green. In the city, where sulfur compounds from exhaust come in, it becomes more dark green. But here's the kicker. Patina protects the copper underneath. It forms a dense, solid layer that functions like a protective shield. Under this green skin, the copper remains intact, sometimes for centuries. That's why old copper roofs look green, but if you scrape them off, red metal still shines underneath. Copper doesn't rust, it gets a suit. The Statue of Liberty is the perfect example. It's made of copper, built in 1886, and when it was new, it gleamed red gold like a giant penny. Today it's green, but under that green patina, the copper is still there. Protected, preserved, almost untouched. The statue hasn't rusted, it's just gotten dressed. And now comes the question, why doesn't iron do that? Why doesn't rust form a protective film? The answer lies in the structure. Iron oxide has larger molecules than pure iron. When it forms, it needs more space. That leads to tensions, cracks, pores. The layer is unstable, it crumbles, it lets everything through. Copper carbonate, on the other hand, is compact, dense, solid. It fits perfectly on the copper underneath and seals it off. You could say iron is like a sponge that gets wetter and wetter until it falls apart. Copper is like a suit of armor that gets denser the longer it's worn. But wait, what about other metals? Aluminum, for example. Aluminum rusts too, but nobody talks about it. Why? Because it happens lightning fast. As soon as aluminum touches air, a paper-thin layer of aluminum oxide forms. Gray, transparent, so thin you can barely see it. But it's there, and it's perfect. No water gets through, no oxygen, nothing. Aluminum rusts in microseconds, and that's exactly why it never rusts again after that. It immunizes itself. That's the reason why aluminum foil doesn't disintegrate, why aluminum windows last forever, why airplanes are built from aluminum. Not because it doesn't rust, but because it rusts so quickly that it protects itself. Brilliant, right? Then there's silver, which tarnishes black. That's also oxidation, but instead of reacting with oxygen, silver likes to react with sulfur in the air. It forms silver sulfide, a black layer that develops on old silverware. That's also a kind of rust, just in black. Silver is the goth among metals. And gold? Gold does nothing. It doesn't oxidize. It reacts with almost nothing. It just stays golden. That's why it's so valuable. Not just because it's rare, but because it lasts forever. Gold is the metal that won against time. It's the only player who ignores the rules. So what do we learn from this? Rust isn't just rust. It's a chemical reaction that proceeds completely differently depending on the metal. The color depends on which molecules form and how they reflect light. Some metals rust destructively, others constructively. Some turn red, others green, some black, and one doesn't change at all. And that's the beautiful thing about chemistry. It's not abstract, it's everywhere. Every color you see tells a story about atoms dancing with each other, reacting, forming new structures. Rust isn't just decay, it's transformation. Iron becomes something new. Copper becomes something protective. Silver becomes something dark. Next time you see a green copper statue or a rusty bridge, remember, that's not destruction. That's chemistry in action. Each metal ages in its own way. Some dramatically, some elegantly, some invisibly. And they all tell us what happens when time, oxygen, and water meet. Because nature doesn't just paint with colors, it paints with elements. And sometimes the result is red, sometimes green, and sometimes just beautifully transient. So stay curious, and if you like chemical stories like this, subscribe to the channel, because this is where your curiosity gets satisfied. And if you sometimes wonder why you forget why you entered a room, or why cats always land on their feet, you'll find the answers in these videos. Enjoy!